Thank you, Alicia. It's very nice to be here today and to talk to you about quality metrics to improve code quality. So let's get started. Good. Should be seeing my screen now. So we're going to start right in and talk about, just to anchor the discussion, I'll use this graphic to illustrate the software development phases. Now, the process that you have might be different, and for many projects they'll have a slightly different order than what you see here, and the time is not necessarily the order as what I'm showing, but it just gives you a general idea of the types of testing that happen in a general software process. So let's go through the steps. Over to the left, you'll notice that there are steps that involve the thoroughness of the testing and the code quality, and they include things like static analysis and code coverage and unit testing. And if you're doing test-driven development, for instance, you might do unit testing first as the first step in the quality process that you have, because you'll be defining your tests up front and then doing the coding and then having the test pass as you're doing the coding. So again, the order of these things is not in time order, but they do represent the steps that most people go through as they go through their software development process. Then if you look in the middle, there are steps that have to do with the code correctness or the correctness of the software itself. In the middle are the activities that are associated with correctness, like integration testing. And here is where we would map test cases with requirements, perform the integration testing with multiple units, and check for any regressions in the code that might have already been developed. So those are the steps that are associated with correctness. And then over on the right are the optimization phases. That's where the majority of the code is already developed, and we enter into this last phase where we're addressing gaps in requirements and working down the defect backlog. So those, in general, are the three phases where we talk about thoroughness, we talk about correctness, and we talked about optimization, and the different types of testing that are done in each one of those phases. So since we're talking about metrics, let's think about the kinds of metrics we might want to collect in each one of these phases and the types of testing represented within the phases. So I'll just pick a few examples. If you look over on the left again and take a look at static analysis, you can see that some of the metrics we might want to collect are things like the number of static analysis issues that were found in the code and the percentage of code that have no issues whatsoever. Those two metrics might be very useful for your project. Maybe you've got a quality target where you won't deliver the code until you're completely free of any static analysis defects. So that percent clean has to be 100% in order for you to trigger the release of the code. Or maybe it's some other benchmark like 80% or 50%, whatever it is for your project. Collecting that metric can help drive the quality of the product. You can, once you measure it, you get an idea of where the code quality is and where it is that you need to be. Let's take another example. Let's take a look at unit testing. With unit testing, I might want to know the number of failed tests that I have in this phase, and possibly might want to know the percentage of the tests passed. Again, those two metrics would be helpful if I want to do, say, some project engineering tasks where I'm taking a percent complete on that phase of the project, and I need to know the percentage passed because I'm going to use that as a percentage complete metric in the project. So let's contrast that with regression testing that you see over in the correctness phases. In regression testing, I've already done the testing for the code, but I've made some code changes, and now some of the tests that had passed are now failing. So that's the number of regressions that are happening. So those are steps backwards in quality. We had passing tests, and now we're moving backwards to having some tests that aren't passing, and that of course is a problem, but luckily we caught that during the regression testing phase, and we can take steps to actually work on those things and get the code back to the level of quality it was before we made those code changes. Okay, so those are the testing phases and some example metrics that we might collect within each one of the phases of software development. So no matter where you are in your current software project, it's going to be an unusual situation for you to be starting with a completely clean slate of paper. No code has been written. The requirements are fully fleshed out, and you know exactly what to do as your next step, and you can put a quality process in place right from the very beginning. That's a great place to be if you happen to be there, but most folks are starting a quality process either with code that's already been developed in the past and they're inheriting that code as legacy code, if you will. Maybe you're using open source software, so you're taking software assets from the open source community and bringing that into your project. So no matter where you are, we should start right away today with doing a quality assessment, and it can be a pretty daunting task. As you stare at the schedule that's on your desk, it'll be hard to know where you want to begin as you take a look at all of the tasks that you have to complete and the quality targets that you have for this project, and coming up with some metrics that make some sense can be a little bit hard to do, but by using some tools that we'll show you here, it'll make that job a whole lot easier, I hope, for you. So one of the tools that we offer is an analytics dashboard, and you see a snapshot of the dashboard here. And one of the things that the dashboard allows you to do is allows you to quickly dial in and see some metrics about your software project. The nice thing about it, and as I get to the end of the webinar, I'll be showing this in a live demo, but you can get this dashboard up and running on your desktop with a single click of a button. So if you're using VectorCast and you've done some tests, maybe you have some regression tests from the legacy software that you have, whatever the case may be, wherever you're starting, you can click a button and you can get an assessment of where that code is today with regard to some quality metrics. So I'm just going to highlight a few things here, and again, we'll be seeing a little bit more of this in the demo, but you can see that up at the top there are some general metrics that are important for you. These are probably going to be the big things that your project looks at from a quality perspective. So the number of statements that have been covered by the tests might be a metric that you really want to track, so you want that right up at the top in big bold letters so that everyone can see where that metric is. Over on the left-hand side, you've got a panel that shows the files that are in this particular project, as well as the functions that are in those files. And because I've got the statement coverage highlighted in this particular screenshot, the order that you see down below is the order of the percentages. So you can see that they're ranked by percentage down below. Over on the right-hand side are some more details to the metrics, breaking them down by, for instance, code complexity, the number of files that I have analyzed, the number of functions that are in those files, the number of statements that are in the file, et cetera, et cetera. And then at the bottom you see part of a heat map, and we'll be using that heat map to drive some decisions about where we want to concentrate our efforts for code quality. So at the push of a button, you pop up this nice diagram, and you're able to get some really good metrics about where your software is at today, and to use those metrics to drive some decision making about where you want to focus your efforts to improve code quality. Okay, now as part of the assessment of where we are at code quality, what we want to do next is take a look at some risk areas that we have. All of us have limited budgets and limited resources to apply to improving the quality of the software, and we want to make sure that we're putting those resources in areas that are most effective. So by doing that analysis, we can go to the next step and actually identify the risk areas that we have in the code. And let's take a closer look now at that heat map that I showed you previously. Now, on this heat map, you can see up at the top that I have a legend that tells me the number of statements is representing the size of each one of these rectangles, and the coverage refers to the colors that you see in the heat map. So by combining those two together, I get a nice landscape of the number of statements that I have and the coverage for those statements, and I can use that to make some decisions about where I want to focus my testing next. Now, intuitively, you'll see that the code that the boxes that are shaded green and possibly even the yellow colors are areas that are pretty well covered right now. They have very, very good coverage from a code testing, software testing point of view. But some other boxes look like they're troublesome, especially the one in the top left-hand corner. Now that LVM.C looks like a real problem because it's red, meaning that it has no coverage whatsoever. So all of the tests that I've run so far have not exercised any of the code that's in that file. And it's a large file. It's got quite a few things in it, and that looks like a pretty good candidate where if I wrote some tests that have to do with the functions that are inside that part of the code, I'd get a pretty good return on my investment. So again, I pushed a button. It gave me some information about the quality metrics that I have for the code. I get this nice heat map, and now I can make some informed decisions about where I want to put the resources that I have available to me to improve the level of quality in my software. So as I mentioned at the top, very few of us have the opportunity to start with a completely clean piece of paper when it comes to a software project. More than likely you're starting with legacy code or with open source code or code that you've inherited from other parts or divisions of the company, whatever the case may be. And as it always is the case because of what you see in this Venn diagram, many times there are shortcuts that are taken, there are things that are left incomplete, and we call that technical debt. Technical debt is when we rush to get something out the door but haven't completely satisfied all of our requirements that we have for quality. There's a huge, huge benefit for having first to market advantage, and that first to market advantage causes us to deliver software before it's ready to go out the door, and that is technical debt. You have to have a plan for addressing technical debt. You have to assume that will happen on every single project, but getting an assessment of it or a measurement of it is very helpful so that you can see how bad that technical debt is affecting the overall quality of the software. And we never can get to the case where we're delivering on time and at very low cost and at very, very high quality. That's an ideal that we all strive for, but we always have to sacrifice one over the other. And it's usually time that is the one that gets sacrificed and stuff goes out the door before it's completely tested. So what can we do with metrics to try to capture that technical debt and make some decisions about what we want to do to address that technical debt? Well, one way you can think about technical debt is to take a look at code complexity. Complex code tends to happen when we rush through things and don't take the time to do the architectural studies and trade-offs that are needed for the code to be simpler and easier to understand, and by the way, easier to test. So one metric that is a nice way of measuring technical debt is code complexity. Well, right within VectorCast, we have tools that allow you to measure complexity, and the report on the dashboard will actually give you this nice table that shows you the functions that have the highest complexity. So if you look here, again, it's that troublesome LVM.C file that we showed in the heat map is again showing up in the high complexity by function table. So it's got a complexity rating of 152. That's very, very complex. That would be a great candidate for some architects to spend some time, look at that file, take a look at the functions that are in that file, and see if there isn't a better way to restructure that code so that the complexity goes down. We can drive up the quality by making it easier to maintain and easier to test, and we can assess the quality of that code much easier and maintain it over time in a better way than when it has a complexity rating of 152. The others are complex as well, but if we've got limited resources, we can use these metrics to drive our behavior and apply those resources to where they can have the most effect. One of the things that works really, really well in a quality process is to have everyone on the team involved with quality. So we don't want to have quality be the job of just the quote QA part of the company. If only QA cares about quality in your company, then you won't get the results that you're expecting to get. What you want to have, the best practice, is really to have everybody involved in quality and have everyone understand where you are at with regard to the quality metrics. So one of the things that is easy to do to inform folks about the quality that you have is to make sure that the quality metrics that you're collecting are get published to the team as a whole. This is a web-based tool that we have, this dashboard. So it's easy to bring up a browser on every desktop and be able to see the quality metrics that you have or whatever tools that you have available to you. One thing that's has been used in companies that I've worked for in the past is to just publish these metrics right in the lunchroom. Everybody gathers at lunchtime, they're able to look up on a monitor and see where we're at from a quality perspective. We can see the number of defects that were introduced into the code. We can do things like see where we are from a passing test perspective. On this particular chart, we're at 50% passing test. If you look at that objectively, you might say, gee, that seems kind of low, only half the tests are passing. But maybe we're early on in the project and our target for passing tests right now was maybe, say, 20%. So we're actually ahead of where we thought we would be from a passing test perspective. That's really helpful for people to know. And you have everyone on the project contributing to the quality, and that's what really drives quality up. When everybody participates, when everybody knows where we're at, and you have the ability for everyone to know where you stand, then you have that feedback effect going back into not just the code, the tests will get better, the integration phases will go better, and you'll have a much better product overall. By the way, if you can figure out a way to do it, it's nice to be able to publish these metrics to your customers as well. If your customers are concerned about quality and getting quality software deliveries from you, it would be really nice if they had some insight into what the quality is of the software that you're delivering. So everyone on the team, whether they be customers, subcontractors, whatever, having a way to publish the quality metrics is a way for everybody to get on board to make the quality much, much better across the board. Okay, thanks. I think you should see my screen now. Is that right?
Yes, that's right.
Great. So you should be seeing VectorCast, I hope.
Yes.
Good. Okay. So those of you who are using VectorCast, which is probably most of you on this call, you will be familiar with our Manage project. So this is just the example Manage project that we actually ship with the project, with the product. And I've put up some of the examples that we ship with it. And I'm just going to use this as the basis for saying, okay, I've got this project, I've been doing this work, I've got some testing done, I've inherited some test cases, I want to get an assessment of where I'm at right now. So what we've put in the product is this nice little button up here at the top that says Start Analytics. And when I push that button, in the background we've got a nice automated script that will run for you, and it will automatically pull up a nice dashboard, which I'm pulling onto the screen here, that you can see where you're at right now with regard to the quality metrics. Okay, so one button. I didn't have to write anything. I didn't have to code up a bunch of Python scripts. I didn't have to do anything except push a button. And it's actually using the data that we store within VectorCast to populate all of this information about the software project that I've got going right now. So if I take a look at this, I can see that I can identify some risk areas that I have in this project. And what I'm going to do is I'm just going to dive down here into this manager project down here. So I've got this manager.c file. You can see there's a bunch of functions that go along in there. And there I've got my heat maps that come up down here at the bottom. And as I showed you before, I can identify some risk areas that that I've got here in this code by looking at the red areas that are here in this heat map. So here I've got this statement size versus coverage that we looked at before, and clear table looks like a place that I should really be getting some additional tests in because it's actually red and my statement coverage is at 0%. It's not a great place to be at all. So if I go down here, I can get some more information about these functions that I've got, functions with the least coverage. Again, this is the clear table. I can take a look at this and see clear table. Yep, by golly, it's got 12 uncovered statements. It's definitely a place where if I spent some additional time, I could get some additional quality out of this by ensuring that the code that's been written here actually matches the requirements I have for this particular function. Now, if I take a look at technical debt, I might want to look at something like maybe I've actually got some ADA code in here as well. So if I take a look at the ADA code, I might look at some things like the highest complexity by function, which I see over here, and I look like I've got a function here, which is get next party to be seated. And that one had a pretty high complexity rating. You can see that if you look at the ADA code, it's got a lot of nested if, else statements in here. Maybe there's a better way to code this to make it a little bit easier to read, a little bit easier to maintain, a little bit easier to understand what the code is doing. So if I'm going to have an architect take a look at this and refactor it, this would be a great target if I want to help with some technical debt that I've had. Maybe this complicated else statement came about because we had some requirements creep and we found out that we had to do this thing and we had to do that thing, and it just got added incrementally over time. And instead we can do this a better way, make the code easier to read, easier to maintain over time. Okay, so, and by the way, if I wanted to look at the coverage for that code, I can see that I'm not doing a good job there either, where I've got a lot of statements here where I'm not getting the coverage that I should have for that code as well. All right, so so that's a good overview of the metrics that we have for this, the files that are here, the different parts, the different functions that are in that file, some information about the source code itself, the coverage that happens within the with the tasks that you have, and be able to see that coverage right within the analytics dashboard. But all of this is canned. These metrics are what we ship with the product. We think they make sense, but more than likely there are probably metrics that you have for your project that you would like to emphasize. We provide a lot of metrics right out of the box that we don't show here in this panel, but by changing the actual files that display this information in the web page, we can put an emphasis on different things. And I've got an example here in this tab where here I'm actually have customized the demo to work a little bit differently than what it works like out of the box. Out of the box I had the number of functions that I had and the number of statements, but for my project it's much more important to know about the total tests that I have and the tests that pass. passed and the tests that failed. So I'm going to put those metrics right at the top of my dashboard so that when I click that button in VectorCast, or when I have a dashboard that's available to, maybe this is being displayed in the lunchroom, we can see these metrics right up at the top that are important for my project. So you don't have to take what's available out of the box that's canned, and it's not, that's not a static report that can't be changed. You can actually go in and change the metrics that are being displayed underneath and show you the metrics that are important for your particular project. So suppose there are metrics that are important for you, but we didn't think about it in the canned metrics that we shipped, neither in the ones that we display by default or the ones that you can call up and change based on ones that we've already created. There is actually a way to create custom plugins and be able to change these metrics altogether for the project, for your particular project. So I've got an example of that. And here in this project, the way I've structured this code is I've got basically 3 different phases. I've got a phase 1, a phase 2, and a phase 3. And I've got different code files that are associated with those phases. And I've got this quality score that I've calculated for each one of these components, and I want to see how the quality score is applied over these 3 phases. So in phase 1, I've got a quality score of 100. That sounds great. Phase 2, a quality score of 1. But phase 3 isn't so great. It's only got a quality score of 50%. So that, on average for all 3 phases, that gives me an average of, 0.54. And that gives me some assessment based on the way I've structured my project, a metric that's important for me, and I'm just using the plugin interface in Analytics to be able to come up with this customized presentation of a metric. Not only can you do these bar charts like this, but you can also come up with pie charts. So let's say that you've got some sort of a grade assessment for each one of the components that you have in your system, and you'd like to be able to show the grading for each one of the components. So here I've got a grade of F for 14 of the components. That means 50% of the components that I have a failing grade, and then if I look over to an A grade, 14% have an A grade. These grades and what they mean are completely definable by the plugin, so they can mean anything that you want them to mean. They can be pie charts, they can be line charts, you can do histograms over time. It's whatever is important for you and your project. So the point I'm making here is that you've got canned data that gives you a wealth of information right out of the box. You can change those metrics around to suit the ones that are important for your project, and then you can make customized metrics based on the information that you have for your project and the metrics that you want to track for quality. Okay, so that's an overview of the Analytics dashboard, and I hope that gave you a good feel for what you can get out of the Analytics dashboard to make it easy for you to understand key performance indicators that you would like to be able to concentrate on in your project. Okay. So that was the demo, and just to summarize these things, I want to make sure that you come away with an understanding of the steps that it takes to go about improving the quality and using metrics for them. So the first step that we talked about was make an initial quality assessment. Very easy to do with the dashboard. Click a button and you get instant metrics about your project. The next thing, identify the risk areas. Use those heat maps to figure out where the parts are of the code where if you put some effort into it, you'd get a big return on investment. What risks you have, what gaps you have in the code base from a quality perspective. Capture your technical debt. Take a look at things like complexity, functions that have gotten out of hand. Have an architect look at those things and invest some time to bring them back in line with what you expect for a complexity metric for your code. Everyone's involved with quality. Use those quality metrics and publish them out to the world. Make sure everyone knows where you stand on quality and have them participate in making the quality better on the project. Identify which key performance indicators you need to focus on, and then use those key performance indicators to drive quality. You can take a look at complexity and coverage as examples of metrics that you can use as a quality metric to drive quality, or whatever metric is important for your project. So those metrics help you prioritize those limited resources that you have and put the biggest bang for your buck out of the resources that you have. All of us wish we had time to completely test everything, but with the limited resources that we have, let's make sure that we're making informed decisions about where they should be applied. And then third, and lastly, I showed you how to take advantage of the custom dashboards so that the metrics that are important for your project are the ones that you can keep track of right on your desktop in real time. Okay, last thing I want to show you is that we do have a live demo for analytics. The URL is here, and it's a real secret username and password. It's typed right here. And what you'll be able to do is, with just by typing that URL in, you can actually get access to a live database and be able to take a look at the analytics dashboard. And one thing that we've done, I'll actually show it to you over here. One thing that we've done is we actually have a live tour that you can actually step through, and it will show you all of the different parts of the dashboard and what they mean, and you can be able to click on things. It's live data, and you can be able to see the different parts of analytics, get a feel for what a real live dashboard would look like, and it's also an example of having this data be published to the entire team. So anybody who logs in can get access to this information, and it's a way to publish all of this information right across the team. And you can see that there's actually a lot more information in this dashboard than I had in my sample project, because this is a much, much larger database of information that we're pulling this data from. Okay, so now we're up to question time.
Okay, great. Thanks, Jeff. We have a lot of questions to get through. So let's just dive right in. Okay, the first question is, what programming languages does VectorCAST support?
Okay, that's a great question. So we support the C language, C++, and Ada.
Okay. The next question is, what are statements?
What are statements? Statements are lines of code. The programming language that you have will define statements slightly differently, but it's essentially the way your language defines a line of code. That's what a statement is.
Okay, and how is complexity measured?
So we use standard algorithms for deriving complexity. They're ones that are commonly used as best practices for determining the complexity algorithms. If you need to know the details of the algorithm that we use, we can supply that to you. There are other ways to measure complexity as well, and if that was important to you, it's easy to integrate in a utility that would do that kind of calculation and be able to use that metric. So the one that we calculate uses a very standard algorithm that we can give you the details on. But if there's a different algorithm that you prefer to use, that's fine. We can bring that one into the dashboard as well.
Okay, next question. Does the heat map cover only metrics from code, or does it take risks identified by business as well?
Yeah, so the business intelligence aspect of it is where you would do a custom plugin. So if you have some business intelligence information data that you'd like to correlate to your testing activities, that's where a custom plugin would come in, and you could integrate in that data into the data that we have in the VectorCAST database and be able to get heat maps that are based on those two factors. So it's possible with a custom plugin, but what we do in the heat maps that we deliver is the information is derived from the data that we have in the VectorCAST database.
Okay. And have you got any real-life examples on how VectorCast can support TDD or ATDD techniques?
Mm-hmm. Yeah, so TDD is a development process we've been spending a lot of time on. I think we've actually done a webinar, or at least some other things that we've put out there, where we go through the process of defining tests up front and then having the code be filled in for those tests and show the percent completes, or not the percent completes, the percent of passing tests changing as the code gets developed. So it's a workflow that we support directly in VectorCast. Was the question, do we have real-world examples?
Yes.
Yeah, so we have real-world examples in the sense that we have customers using that methodology and using VectorCast to support that methodology. I think that's a real-world example.
Okay. Next question is, how do you get the coverage data of tests to code?
Coverage data of tests to code. So I think what you mean by that is which tests cover that line of code. So if you took a line of code, you'd like to know what test covered it, and
okay.
That information gets stored. Assuming I interpreted the question correctly, then we
Yep.
store that information in the database when the tests get run, and we know which test covered that line of code.
Okay, and the next question is how much its SLOC count can this can handle, or number of source files in a project?
Yeah, I haven't tested it to the upper limit. I don't know what the upper limit is. I guess it would depend on how large the database gets. We have customers with millions of lines of code, so the slot count can get very, very large, and VectorCast has handled that. I don't know of a case where we've gone to a level where we couldn't handle from a source lines of code slot perspective. Hasn't been the problem. The issue tends to be more of the resource constraints on the target environment. So if you instrument all of the code at one time, it might be that the instrumentation plus the code is larger than will fit on your target hardware. But we actually will be coming up with a solution for that very, very shortly, where you'll be able to define a subsystem or a component, and using that component will instrument just that component and be able to get past the resource constraints that you have in your target environment. If you're doing host-based testing, that's generally not a problem. Usually the host has plenty of memory and disk space to be able to hold the instrumented code. The problem tends to come in from a size perspective on the target hardware, where maybe you've got limited memory or limited storage, and again, we have a solution for that as well.
Okay, great. It's possible to make is it possible to make a relationship matrix with the test and requirements, uploading the requirements on VectorCast or something like that?
Yes. Not only is it possible, but it's integrated right in the tool. So the tool VectorCast has a way of importing requirements from several different requirements repositories. Even a simple repository like a Excel spreadsheet that holds your requirements. You can bring that into VectorCast, and we can map the requirements to the test cases, and you can get an understanding of what the coverage is, of the number of requirements that have been tested in that system. I think I answered that question correctly.
Yes. Jeff, could you do me a favor and show the link to the online demo page?
Sure.
Again, we're getting a lot of requests for that.
There it
Great.
is.
Thank you. Okay. The next question is how to integrate VectorCast with on-target test data.
Okay, so I think what you mean by that is you have maybe some configuration database, for instance. Maybe there are some optimization vectors that you've got set up for your code, and your code at runtime is going to read in those vectors and change its behavior based on the calibration settings that you have set for that. That is a very normal situation. We have many customers who do that, and it's simply a matter of setting up the we have an adaptation layer for VectorCast for when it runs on the target itself, actually on any target. And in that adaptation layer, we account for that data space to be there. And we just run the code as you normally would, and the instrumentation will be able to pick up things like coverage and return parameters just fine. So the tool is accounting for the fact that you've got data that's sitting on the target that's being used for calibration or for configuration information.
Okay. And I think we have time for one more question, Jeff.
Okay.
The question is, if I don't use VectorCast, can I still get access to the dashboard information?
Fantastic question. So yes, the way we've structured the product is we want as many people as possible to get access to this data. If you purchase the product at the enterprise level, there are a certain number of dashboard seats that you get as part of that package. But there, any number of additional seats that you require can be added on, and you can have your entire team have access to individual dashboards if that's what you want. So yeah, we've structured the product so that everyone can get access to the information.
Okay, great. That is all the time that we have for today. I would like to thank you, Jeff, for your wonderful demonstration today. If we didn't get to answer your questions live today, someone will be in touch with you to answer your questions, and we will get answers to them as soon as we can. Please feel free to email us at info@vectorcast.com if you have any suggestions or questions, and thank you for attending the webinar today. Have a great morning, afternoon, or evening. Thank you.